Hey everyone, and welcome to today's explainer. So let's dive right into something that honestly might sound super technical at first, but is actually incredibly intuitive once we break it down. Today we're unpacking one of the absolute core building blocks of machine learning, decision trees. Now, I know, if you've ever felt totally overwhelmed by, thick tech jargon or massive algorithms, just take a deep breath. We are taking it completely back to basics today to explain decision tree algorithms in the easiest way possible. By the end of this, you're going to see exactly how machines process information and essentially think. And honestly, you might just realize that this fancy computer logic, it's basically exactly how you and I operate every single day. To really get how a machine learning model thinks, let's just take a quick step back and look at how you think. Ask yourself, should I go out today or not? It's a completely relatable, everyday choice, right? We all make it. Now, when you face this in real life, you don't just randomly guess yes or no out of thin air. You're actually going through this highly structured, deeply logical mental process. You're weighing different conditions, looking at the environment, checking your personal preferences, and it happens so fast, so seamlessly, that you probably don't even realize you are literally running a sophisticated algorithm right there in your head. Let's actually break down the mechanics of that exact thought process. First up, your brain takes in the environment. You check the weather. Then, based on that very first observation, your brain asks a specific question. Is it raining? If the answer is yes, well, you weigh that data. And maybe your final call is to just stay inside, maybe grab a cup of tea. But if the answer is no, your decision is to step out and enjoy the day. Notice what's happening here step by step. Every single question you ask yourself leads directly to the very next decision. You are literally branching out your thoughts based on changing conditions until you hit a final, solid conclusion. So, a decision tree is simply a model that makes decisions through a sequence of questions. The clue's right there in the name: decision plus tree. That everyday human thought process we just walked through, that is exactly what a decision tree is in the machine learning world. It's literally this tree-like structure that branches out to make calculated decisions. The only real difference between your brain deciding to go outside and a computer's algorithm predicting an outcome is that, well, in machine learning, the computer looks at huge amounts of data and mathematically figures out the absolute best questions to ask. So where exactly do we use this in the tech world? Well, decision trees basically do two main jobs. You can kind of think of this as a massive fork in the road for the algorithm. On one side, we have classification. This is where the final output the machine gives you is a specific category or a label. On the other side, we have regression, where the output is a continuous number. These are the two primary paths a decision tree can take, and the direction it chooses, that depends entirely on what kind of real-world problem the data scientists are actually trying to solve. Let's see how classification actually plays out in reality. When a decision tree is doing classification, the algorithm is aggressively sorting data into very distinct, separate buckets. Think about everyday scenarios for a second. Is an incoming email spam or not spam? Yes or no? Will a student pass this exam or fail it? Will a customer buy a new product or pass on it? These are rapid-fire categorical answers. The machine isn't, guessing some infinite value or a random decimal. It's classifying the data into clear, predefined groups based on its internal questions. It's a binary, definitive sort. But hold on. What happens if the answer we need isn't just a simple category? Think about a massive number, something like 72 million, or maybe 7.2 crores. This perfectly illustrates regression. In a regression decision tree, the output is always a continuous number, not a categorical label. The answer here isn't a category, it's a specific numerical value. So if a real estate machine learning model is trying to predict a house price, the answer isn't a simple yes or no. The answer could be 45 lakh, 72 lakh, or 1.2 crore. Whenever the algorithm needs to predict an exact number based on historical data, it completely relies on regression. Okay, let's tie all of these concepts together with a really practical, high-stakes scenario. I want you to put yourself in the shoes of a business owner. Imagine you're running a major tech company. It's the end of the quarter, millions of dollars in marketing are on the line, and you want to predict something absolutely crucial for your sales. Will this specific customer buy a new mobile phone? You've got massive spreadsheets full of customer data, demographic details, past shopping habits, everything. But how does the machine actually build the logic to give you that specific prediction? Well, let's construct this decision tree step by step, just like the algorithm does, to see what it actually looks like under the hood. The very first piece of the puzzle is called the root node. This is the topmost node right where the whole decision-making journey kicks off. It's the absolute peak of our tree. The algorithm scans through all your historical customer data and mathematically picks the single most important question to split the audience right out of the gate. In our mobile phone scenario, maybe it determines that wealth is the biggest factor, so it asks, is their income greater than $50,000? Everything flows downward from this single critical starting point. Honestly, if you get the root node wrong, the whole tree leans the wrong way. Once the customer's data filters past that root node, the machine gets a bit more investigative. It pauses, processes that first answer, and then gets curious with follow-up questions to dig a little deeper. It might ask, wait, is their age greater than 30? Or maybe have they made a previous purchase with our brand before? These middle points in the sequence, we call these our internal nodes. The algorithm uses these internal nodes to continuously narrow down the customer's exact profile. With every new internal question it asks, it's slicing the data thinner and thinner, getting closer and closer to a highly accurate, personalized prediction. Now, how do we physically get from one node to the next? Well, that is where branches come into play. Every time a root or internal node asks a question, the branch represents the actual answer provided by the data, like a simple yes or no. Every single branch is one possible answer. You can think of them as the physical pathways that route our customer's specific profile right through the tree. Depending on who the customer is, these branches constantly steer the logic left to right, navigating through this whole maze of conditions based entirely on their unique individual details. And finally, after traveling all the way down those various branches, we reach the end of the line, the leaf node. This is the ultimate destination of the algorithm. Buy or don't buy. Once the customer's data hits a leaf node, the outcome is absolute. No further questions will be asked. The machine stops analyzing, the questioning completely ceases, and your business prediction is perfectly delivered. The leaf node represents that solid final answer that the entire complex tree was painstakingly built to discover. It is incredibly fascinating when you map out this algorithm step by step like this, isn't it? It really makes you realize that machine learning isn't just, cold robotic math running in some distant server. It's actually modeled directly on the very structure of human logic and deduction. So, I'm going to leave you with this final provocative thought. Think about your routine for the rest of today. How many of your daily human choices are actually just invisible decision trees operating silently in your mind? The next time you make a simple choice, remember, your brain is running the exact same beautiful algorithm we just explored. Thanks so much for joining me for this explainer, and hey, keep observing those invisible trees around you.